Alright guys, today we're talking about quadratics. Now before we really get into this lesson, we've got to go over kind of about, I don't know, 10 or so um, vocabulary terms of what quadratics are, different things that have to deal with quadratics. And the first thing we're going to start with is the quadratic function, which is this right here. You got f of x equals ax squared plus bx plus c. Basically, what that's saying is that you have function x or y equals, remember f of x is the exact same thing as saying y equals right here, okay? So we have f of x equals a number times x squared plus a number times x plus c. And here's an example. You might have just simply x squared, let me finish that out right there, minus 6x plus 8. This is an example of a quadratic function. If I asked you what the a, b, and c terms were in this, you would simply tell me the coefficients of each one of these terms, and then the constant down here at the end. So my a term here would be 1, because it's always understood there's a 1 in front of a variable, unless there's another number there. My b term is going to be negative 6, just like it is right here. Again, we're just looking at the coefficient in front of the variable. And then my constant term, which is this very last one, is going to be c. So c and constant. That should make it really easy to remember. My c term, or my constant, is 8 in this case. So we have 1 is my a term, negative 6 is my b, and then positive 8 is my c. Alright, now the next vocabulary word we're going to talk about is a quadratic equation, where this time you'll see the same thing we had, ax squared plus bx plus c. This time it's going to be set equal to 0. Alright? And just sort of a sidebar on this, a, b, and c are all real numbers, so they're real numbers, they're not imaginary. And a, the first term here, cannot equal 0. For it to be a quadratic equation. So any real number except for 0 can go right here where this a is, okay? And here's a couple of examples of that. We've got x squared minus 3x minus 4 equals 0. This is a quadratic equation. X squared minus 9 equals 0. Now notice the difference between this one and this one. This first one we just looked at is a trinomial. You have 3 terms here. And this one's only a binomial. You only have 2 terms. What are we missing here? We're missing the middle term. And how do I know it's the middle term, the b term? Well, x squared, if you see this right here, is always going to go with the letter a. The c, or your constant, is always going to be just a regular number. So negative 9, for instance. It doesn't have a variable with it, which means we're missing the middle term, b, because the b term is always going to have a variable with it, an x or a y, but it's just going to be an x typically in most cases. So we could also write this like this: x squared plus 0x, if we really wanted to just show that middle term, minus 9 equals 0. We could write this, so this right here and this right here are the exact same thing, but you don't have to put that 0x there in the middle. So these are examples of quadratic equations. Now in this next definition, we're talking about the standard form of the quadratic equation. Now we've talked about standard form before, it's been a while, but what standard form simply means is that you're going to be in descending order with your exponents. So obviously x squared has the biggest exponent, x to the first power would come next, like right here, and then this one doesn't have a variable at all, so that one comes last. So it's always going to be in descending order, so it's going to be getting smaller in terms of your exponent on your variable. So x squared is bigger than x to the first, so that one goes first. So it goes x squared plus 4x to the first plus 5. And then it always equals 0. So this right here is what standard form of the quadratic equation looks like. This is not what's, so let me write it like this. So we have 4x plus x squared plus 5 equals 0. This is not in standard form down here because it's not in descending order. x squared must come first in order for it to be in descending order and for it to be in standard form of the quadratic equation. That one's a pretty easy one. Alright, so our next thing we're going to talk about is a discriminant. And discriminant is simply looking at a quadratic equation like we have up here in the top, and we have to pull some information out of that. What we're specifically going to pull out is this right here. It's in a little expression, b squared minus 4ac. So we're needing to pull out a b, an a, and a c and put it into this little formula, and we're going to substitute these numbers in and then solve that, and that's going to give me the discriminants. So let's do that real quick. We have an example down here right below this, 2x squared minus 5x minus 3 equals 0. So this is a quadratic equation, and we're going to find the discriminant of this quadratic equation. So it's real simple. What we want to do is we want to first pull out a b. So I'm going to go to my green color here so I can kind of show you color coordination with what we've got. My b in this example is a -5. Don't forget to bring the sign in front with that number. So since we have -5, I'm going to write it like this. So we have -5, that's my b, squared, minus 4, and it's always going to be minus 4. And I'm going to go ahead and draw out a couple of parentheses here, because I'm going to put my a in this one and my c in this one. So my a in this case is 2, so that's going to go right here. And then my c, what's my c here? My c is a -3. So again, don't forget the sign out in front. So in order to find the discriminant, I simply took my b, which was -5, and squared it, minus 4 times my a, which was 2, times -3, which was my c. And once I do all that, let me work this out real quick. -5 squared gives me a positive 25. -4 times 2 is -8. And then -8 times -3 is going to give me a positive 24. 25 plus 24 gives me 49. And so 49 is the discriminant of this quadratic equation right here. So that's all you have to do, just work with this little formula right here, b squared minus 4ac. And here in a minute we're going to learn how to do the quadratic formula, and you'll notice that this will be part of that big formula. Now the next definition we're going to go over, we're actually going to try and cover two definitions in one here. The first one is a parabola, and the second one is the zero of a function. Now a parabola is simply this shape right here. If I can draw it really carefully, that's a very ugly parabola, but just imagine that as a U shape right there, okay? It's just a straight little U. So no curves in the line except for just a regular U shape, okay? Now, that is what every quadratic function is going to look like. If you were to put this in your calculator and graph just this function right here, so you went to y1, so y1, and you typed in x squared and put that in your calculator and hit graph, that's going to give you just a regular parabola. It's going to go right through the origin at the 0, 0 spot, and it's just going to be a U shape. So that is what the shape of all of these different quadratic equations are going to look like. Now, when I talk about the zero of a function, I'm simply talking about where is it that my y equals 0. So where is it crossing? So here's my x and here's my y. Where is it touching this x-axis at 0? Okay, and that's all you're looking for. Now if I did one over here, and again I'm trying my best to do this straight up and down, this one would have 2 zeros. So it could be about a -1 and a +1, it looks like. And this is example number 6 in your packet. If you're looking at it, on example number 6, it has 2 zeros there. It crosses the x-axis at -1 right here and +1 right here. These are very crude drawings because I'm doing this with a mouse, so it's not very straight, and I apologize for that. But that's the idea of the zero of a function. So if you're ever asked to get the zero of a function, you can simply type in the quadratic equation into your y1, just like we did over here, and then simply see where it either touches or crosses the x-axis. That's literally all you have to do. It's a very easy process. Now the next one we're talking about is a vertex of a parabola. The vertex is, simply put, the highest or the lowest point on the parabola. So you're simply looking at in this case, the bottommost point on this curve, and that is going to be your vertex. It could also, if you had an upside down curve, it would be the highest point, this right here. That would be the vertex. We'll also get into, in a little bit, the maximum and minimum of functions here in just a moment, but that deals also with the vertex. Now, if I asked you what the vertex of this parabola was, what you would do is you would have to give me the coordinate points of this point right here. And it's been a while since we've worked with coordinate points, but remember, you go right and left first. So starting in the origin, starting here at 0, 0, did we move right or left any? No, we didn't. So that's a 0. And then how many did we go up or down? We went 1, 2, 3, 4, 5 up. So the vertex of this parabola is at point 0, 5. Alright, now the next definition is an axis of symmetry. Symmetry is simply talking about if you were to fold something over on itself perfectly. For instance, you could take a sheet of paper, just a regular notebook paper. If you folded it right down the middle, hot dog style, it would fold over perfectly on itself. You could also fold it hamburger style, and it would fold over on itself perfectly. There are lots of shapes that do this, and what we're talking about in the quadratic sense is taking this graph right here. It's an upside down parabola, and we're going to simply cut it in half where it is going to would fold over on itself. So if we folded the right side over onto the left, aside from the fact that I can't draw very well, this should fold over on itself perfectly, and that means it has an axis of symmetry. This line right down the middle is your axis. That is what we're talking about, where it actually folds over on itself. You could also have a regular parabola like this right here, and then your axis of symmetry would simply be right through the middle, and it would that's the line where it crosses over, where it will be folded over on itself. So that is, it actually is technically termed a line that divides a plane figure or a graph into two congruent reflected halves. Congruent simply means equal in math terms. So if you ever hear the word congruent, that means that this half is congruent to this half. They are equal to each other. Alright, now the last two definitions we're going to talk about are maximums and minimums of quadratic graphs. So if you look down below here, we've got two different examples of quadratic equations and functions, and what we're trying to do is determine what is the maximum point and the minimum point. It's actually a very easy concept. You're looking at the vertex of each of these. Remember, we talked about vertex earlier. Vertex is the highest or lowest point on the parabola. And so just simply looking at this one right here, what is the highest point you come to? So look at your vertex, and you can see it's right here where I've got this point. So that means that this one has a maximum, and the maximum is going to be simply up 1, 2, 3. So my maximum on this first graph is 3. Now similarly, if we look over at this graph over here, we're going to look for the vertex again, so either the highest or the lowest point. And if you notice also these arrows on the ends of this, that means it's going to keep on going in that direction forever and ever. It's never going to stop. So you can't find a maximum on this one, because this one's just going to keep getting higher and higher and higher. So we have to look for a minimum. And again, so this is the lowest spot on this one. So if we look down here, we look at 1, 2, 3, 4, 5, which means that this is going to have a minimum of a -5, because remember, we went down, not up this time.